Hello everyone, this is Mrs. Lopez and we are in grade 7, module 1, lesson 13. Today we are learning how to find equivalent ratios when we have the total quantity, I want to say. And need to change that to quantity, sorry, quantity. And we are kind of did it before with the whole numbers, but right now since we are working with fractions and mixed numbers, it brings it to a whole new level. Okay, so we are on the example 1 pizza. You're working at your local pizzeria specialty home restaurant, and listed below are the amounts of meat used in one Meatlovers pizza. So we have 1/4 cup of sausage, 1/3 cup of pepperoni, 1/6 cup of bacon, 1/8 cup of ham, and 1/8 cup of beef. What is the total amount of toppings used on the Meatlovers pizza? How do I find the total number of toppings? I would add them all together, right? So I will use 1/4 plus 1/3 plus 1/6 plus 1/8 and plus another 1/8. When we add fractions, we need to make sure that we have a common denominator. So we are going to find a common denominator for all of these denominators, for 4 and 3 and 6 and 8. This one is actually pretty easy. If you know your multiplication table, you know that 24 would be the least common denominator for all of these ones. 4 can go into 24, and 3 can go in it, and 6 and 8. So now let's see. We need to change all of the numerators based on the new denominator. 4 goes into 24 6 times, so we are going to multiply 1 by 6, and that is a 6. Then we have 3, it goes into 24 8 times, and so we'll add 8. And then we have 6 goes into 24 4 times, and we are adding 4. 8 goes into 24 3 times, we are adding 3, and another 3. Okay, we changed all of our fractions with a common denominator, and I just put all of these on top of the 24 because that's what we are going to do anyways. So we have 24ths, and now we are adding 6 and 8 and 4 and 3 and 3. So here I have 10 right here, and I have 14. 10 and 14 is 24. So I actually have 1 cup, 1 full cup of toppings. The meat must be mixed using this ratio to ensure the pizza is the same every time. So think about how you're going to a restaurants like Burger King or Dunkin' Donuts or um, another type of restaurant that you can find everywhere. And let's say you go to Dunkin' Donuts um, right on the main street by the school, and then you order your favorite food there, and then you go to a different Dunkin' Donuts just down the road, and you order another favorite food there, but they're not the same. So that doesn't work. In all of the Dunkin' Donuts, we always need to make sure that they need to make sure that we get the same quality of the food, and it has to be exactly the same everywhere, right? So that's why we have to make sure that the pizza is the same every time, no matter where we are going. The table below shows 3 different orders for the Meatlovers pizzas. So everybody ordered Meatlovers pizza, and it has to be the same. Using the amounts of total for one pizza, fill the missing values. Okay, so here we have all our toppings: sausage, pepperoni, bacon, ham, and beef. Let's look at order 1. Order 1 has 1 cup of sausage. We're looking in one pizza. How much sausage do we need? 1/4 cup. So if it was used 1/4 on one pizza, and in order 1 they're asking for 1 cup, so what happened to that 1/4 that it became 1 cup? It was multiplied by 4. right? So whatever happens to one topping, we have to make sure that happens to all the other toppings, correct? So pepperoni was 1/3. Now we need to multiply it by 4, and we will get 4/3 of a cup, or 1 1/3 cup. Okay? Now bacon. Bacon was 1/6 of a cup. We again need to multiply it by 4 using the same unit rate all the time. We get 4/6, or 2/3 of a cup. Let's see if ham was done correctly. We had 1/8. We are multiplying by 4 over 1. If you want to do that way, you can simplify 4/8 into 1/2, and that works. So beef, it's also 1/8. We are multiplying by 4 over 1, and we are also getting 1/2 cup. All right, so if I look at the total, all of the toppings together is 1 cup. If my order is multiplied by 4, it has to be 4 cups of everything. So now, if you decide, oh, I'm sorry, you couldn't see that. If you decide to count all of them together, you should be getting 4 cups. So you see 1/2 and 1/2 is 1 whole already. And then 2/3 and 1/3 is 1 cup. And we have one more. So we have 1, 2, 3, and 4. 4 cups, that works. Let's look at order 2. Order 2 has to do with bacon here. We only know the order for bacon. It was 1/6. Now it became 1 cup. So what was 1/6 multiplied by to get to 1 cup? That was times 6, right? 6 over 1 times 1/6. So you can simplify and you will get 1. All right, so whatever happened to one topping has to happen to all of the other toppings. So we are going to multiply 1/4 by 6, and we are going to get 6/4, which is 3/2, which is 1 1/2 cup. For pepperoni, we had 1/3 times 6 over 1, and we can simplify 6 and 3, and we'll get 2 cups. Okay, this one we already did. 1/8 times 6. We can simplify 6 and 8 to 3/4 cup. And another 1/8 times 6 over 1 is also 3/4 cup. The total was 1. Since we are all multiplying by 6, you will get 6 cups total. All right. And that does work if you count them all together. Let's look at pepperoni. We know the order for pepperoni for the third order, and we know the order for beef. Okay, so we have 1/8 turned into 1 1/8, or if you want to say 9/8. So what was 1/8 multiplied by to get 9/8? And that is 9. You can also look at what was 1/3 multiplied by to get 3. This one's a little tricky because you will have to simplify there. This one, you can totally say if it was 1/8 and became 9/8, it means you multiplied by 9. This one, 1/3 times 9, we are going to, let me write 1/3 here. We will have to simplify 9 and 3, and that's how it becomes 3. Okay? So for the sausage, we have 1/4 times 9, since that is our order right here. We cannot simplify that, so we will have 9/4, which is 2 1/4 cup. 1/6 times 9, we can simplify 6 and 9 by 3, so we'll have 3/2, or 1 1/2 cup. 1/8 was multiplied by 9, and I'm not going to do the multiplication because we already have it here. 1 and 1/8 cups. The total 1 cup was there. We need to multiply by 9 and we'll get 9 cups. And that should work when you add them all up together. Okay, moving on to the next one. And again, if people start having questions, just ask. It is important that you do ask in class, not to be mistaken by, not to think that you're going to get it later. It's better to always ask and find the answer. Exercises. Okay, so we have number 1. The ratio of the number of miles run to the number of miles biked is equivalent for each row in the table. And we need to complete the table. So before we worked with whole numbers. Now we are working with mixed numbers and fractions and whole numbers and decimals and all of these ways of number representation. So I want to look at what I already know for both bikes, that I can find the unit rate. And since I know it's proportional, I would be able to multiply or divide to be able to get the missing numbers. So I'm looking at the first row here, and I see 3.5 was multiplied by something to get to 7. If you already know that 3.5 times 2 makes 7, that's great. If you don't know it, we always need to make sure that we are getting our constant of proportionality. I would always call the second or the right column y and the left column x, making y the dependent variable. Dependent. And when I divide 7 over 1 by 7 over 1 by 3 and 1/2, which is 7 over 1 divided by 7/2, which we multiply by 2/7, the reciprocal, and simplify this 7 and 2 in the denominator and this 7 and 7 in the numerator, and I will get 2. So that's a way to find the unit rate. However, if you know that 3.5 times 2 is 7, that was a lot easier. That would have been a lot easier for you. So if I know that this is times 2 and I know that it's proportional, I'm going to use that 2 unit rate for all of my rows here. Our formula, y equals kx all the time. And my job is to learn how to use that formula all the time. So I'm going to substitute the numbers that I have by the letters that I have by the numbers that I have. So I have 5 and 1/2 in the y. So I'm going to write 5 and 1/2 equals 2. That's my k. And x is the one that I don't know. That's one I need to find out. How do I find a number that was multiplied by 2 to get to 5.5? I need to divide 5.5 by 2. X equals 5 and 1/2. I'm dividing by 2 over 1. I'm changing 5.5 into improper fraction. So I have 11/2. I'm dividing by 2 over 1 or multiplying by 1/2. 1/2. And I get, to simplify the denominator, and in the numerator I have 11/4, which is 2 and 3/4. 2 and 3/4. 2 and 3/4. Okay? Y equals kx is our original formula for this one. I'm going to write 2 and 1/8 instead of the k, right? So I'm going to find y equals 2 times, and the x is 2 and 1/8. So here I have multiplication, but still I need to make sure that I'm changing my mixed numbers into improper fractions. So I will have 2 over 1 times 8 times 2 is 16 times 1 is 17 8. I can simplify 2 and 8 by 2. 8 becomes 4, 2 becomes 1, and I get 17 fourths. 17 fourths is 4 whole and 1 fourth. 4 and 1 fourth. And we have last one. 3 and 1/3 goes instead of the y. 3 and 1/3 equals 2 times x. To find x, I'm going to divide because I need to see what was multiplied by 2 to get to 3 and 1/3. So I'm going to do 3 and 1/3 divide by 2 over 1, which is 10 thirds divided by 2 over 1, or multiplied by 1/2. All right, simplifying the denominators, and I have 10 and 2 that can be simplified by 2, and I will get 5 thirds, which is 1 and 2 thirds, and that is for the run distance, 1 and 2 thirds. Let's see if it makes sense, if that all makes sense. Just in the context, the distance run should be smaller than the distance biked, right, by 2. So if I'm looking at the second row, this one is about twice as small as this one. This one is about twice as small as this one is smaller than this one. So we made it right. B, what is the relationship between the distance biked and the distance run? We can say it is a proportional relationship. It is a proportional relationship where the distance biked is twice the size of the distance run. Twice the size, or twice the distance run. It is proportional relationship where the distance biked is twice the distance run. So we are multiplying the distance run by 2, doubling it up, and we are getting the distance biked. It is a proportional relationship because the constant is constant. Constant of proportionality is still the same. Okay, let's look at number 2, the last problem before the homework problem. The table shows 6 different ratios to make macaroni and cheese. If the ratio stays the same, how might the recipe be altered to fit different pans? Okay, so we are looking at the one that we know, and that is 3 for the noodles, 3 cups of noodles. And by using 3 cups of noodles, we get to use 3/4 cups of cheese. So noodles is X, cheese is Y, because it's just Y we always like to put on the right side. And to find the K, to find the constant of proportionality, we need to divide Y by X. So we are going to divide 3/4 by 3, or multiply it by the reciprocal 1/3. So we see that when we divide by a number, we just always multiply by the reciprocal. We can simplify 3 and 3, and it becomes 1/4. So I know that 3 times 1/4 has to be 3/4. Okay. If I found this constant, now I can use it. Since I know it has to be the same all the time, I know that I can use that rate to find all the other missing numbers. Okay, so 1/4 was multiplied by something to get to 1/4. This one's easy. I don't even need to show my work. What times itself makes the same number? 1. 1 times any number makes that number stay the same, right? 1 times 1/4 is 1/4. Now let's look at 2/3 times 1/4. 2/3 times 1/4. I can simplify 2 and 4, um, making 4 a 2, and I will get 1/6. 1/6. And then I have 5 and 1/3. I need to multiply by 1/4. And I need to make sure that 5 and 1/3 is an improper fraction. 3 times 5 is 15, plus 1 is 16/3. I'm multiplying by 1/4. I can simplify 16 and 4. 16 becomes a 4, and I get 4/3 in my answer. 4/3. All right, the table is now complete, and it's time for your homework. You have only one problem in the homework, so that should be pretty easy. And let me know if you have any questions. I will see you in class.